A very good afternoon, everyone. Welcome to International Conference on Advanced in Sciences, Engineering and Technology. I, Farhazia, Assistant Professor from Department of Computer Application, Integral University, honored to be your moderator for today's session. We are delighted to have you here with us for what promises to be an enlightening and engaging event. Now, without further ado, let's get started. It is my pleasure to introduce session chair for today. So we have Professor Dr. Sheesh Sir from Integral University. And our second chair is Dr. Soumya Bansal from BVICAM Delhi. Welcome, sir and ma'am. Please join me in welcoming Professor Dr. Sheesh Sir and Dr. Soumya Bansal ma'am to leading this session. I want to extend a warm welcome to all our participants joining us both in person and in virtual manner. We are excited to have a diverse and engaged audience. We have an excellent lineup of papers and authors for today's session. Our first author is Mr. Navinitha Gupta. His paper ID is 115 and paper titled Implementation of Low-Cost ADS-B Receiver Using Software-Defined Radio and JNU Radio. Mr. Navinitha Gupta. Okay, Sheesh sir, please. Here, Sheesh sir is joining us.
Thank you, Farah and Shubham sir. First of all, I would like to congratulate the organizing committee of this international conference and especially Dr. Mohammad Faisal, the head of department, and Mr. Tasneem. And I would like to say best of luck to all the candidates. So let's start. Thank you very much.
Thank you, sir, for your kind words. Here we are going to proceed with our first author, Mr. Navinitha Gupta, sir. You can proceed. Sir, please share your screen and switch on your camera. Yes, sir, you can start.
Your voice is not audible. Please switch on your mic.
Sir, his Sir, Navinitha sir, please try to unmute it from your side. Sir, please log out and log in again. Till that time, we can have Miss Nazish Siddiqui. Ma'am, are you there? Nazish, am I audible to you? Miss Nazish Siddiqui?
Yes, ma'am, you're audible. Am I
Okay.
audible now?
Nazish, please share your PPT with us and start your presentation. Here, Miss Nazish Siddiqui is here. Her paper ID is 123 and her paper title is Comprehensive Review of Approaches for Reliable Data Dissemination in Vehicular Ad hoc Networks. Nazish, please press F5.
Is it visible now?
Yes, it's visible, but make it in running mode.
Yeah, sure.
Okay, yeah, you can proceed, Nazish.
Thank you. Okay. A very good morning to all of you. I'm Nazish Siddiqui from Imperial University, and the title of my review paper is Comprehensive Review of Approaches for Reliable Data Dissemination in Vehicular Ad hoc Network. Thanks. So these are the major outlines that I'm going to discuss here. Very first, introduction to VANET. So VANET, Vehicle Ad hoc Network, is actually a subset of MANET, which is a dynamically created network to connect the vehicles and base stations and other supporting equipments on the road. These nodes on the roads are generally vehicles and the base stations available on the road, which are termed as the roadside units. So it is also called as network on wheels. These are the basic components, the basic elements which are required for a VANET network architecture. We have, like any other communication, we have a sender and a receiver, which are generally the vehicles and the base stations. Next, we have those base stations as the technically termed as roadside units, which provide the communication to the vehicles available on the road. CA is the central authority, the central governing body, or the most trusted authority in this particular network, uh, which is responsible for authenticating all the other nodes connecting the network. OBU is the onboard unit. This may be termed as the main processing unit available on the vehicles, and these also contains the technology for short range communication. TTM, that is temper-proof module. These modules are the temper-resistant modules, like the black box we have, and since it is temper resistant, so we believe that it could not be hacked by the hackers. So it contains all the necessary and confidential information of the vehicle. And DSRC are the basic communication technology, dedicated short-range communication, which are used for the communication among the vehicles in this particular network. So this is the general VANET architecture that I've discussed. Like, we have vehicles available, which are the primary nodes here. We have base stations, which are termed as RSUs, the roadside units, and we have a central authority, CA, which is governing these roadside units. The communication in a VANET are generally of three types. It may be inter-vehicle, between the vehicles. It may be vehicle to the roadside units, and it could be about among the roadside units, the infrastructure. These are the major security concerns that we have in VANET. Very first, the authentication of the sender. Each and every sender must be authenticated, that the data coming from the node, the sender which is sending the messages must be the genuine one, the one that has been authenticated by the central authority, that has been given that has got the permission from the central authority to be present in the network. Integrity of data is another important security concern. The data that has originally been generated should be the one that has to be received at the receiver's end. Then we have non-repudiation. It refers to the fact that the sender could not deny the fact that it has sent the data that is received by the receiver. Privacy of the node is another important concern. We are very much dealing with the authentication of the node, that each and every node present in the network must be first authenticated by the central governing body. But at the same time, their privacy should not be hindered. When they are saying that non-repudiation and authentication should be emphasized, but it is not that the information about the sender should be publicized. Like each and every node available in the network should not know about the identity of each and every node present in the network. It should only be revealed before the concerned authorities. Real-time guarantee, another important concern. Like every message disseminating in the network should be received at the receiver's end at the right time in a time constraint. Like it is useless if it is not received on time. High mobility and volatility, as the vehicles are completely moving in a van, and that too at a very high speed. So the topology or the connectivity is completely volatile. So this is another important security concern. Liability versus privacy, or trade-off between authentication and privacy, is a similar thing as discussed earlier. Like authentication and non-repudiation is important, but at the same time, privacy of the node should not be involved. It should be maintained. Next, we have importance of reliable data in a regular network. Why do we need reliable data? Since we know that nature of regular environment is very much dynamic, the nodes are completely volatile. The network is highly mobile network. So the vehicles come in communication with each other for a very short span of time, and hence the link established between them is for a very short duration. And so the data that has to be sent should be the correct one to enhance road safety, to manage the traffic in the road, to facilitate all the services that should be provided to the drivers or the users that are availing the services of this particular network. So reliable data is a major concern, is very much important in this particular network, so that we could achieve this the safety of the road and traffic efficiency. These are the major challenges and issues that are faced in disseminating the data in regular network. As discussed, high mobility, it is completely a mobile network. And also the connectivity between the vehicles is for a very short duration of time. The communication range is very short, as the standard technology that we use is the SRC. It is a short range communication technology. And also it varies with the density of the network. We have limited bandwidth. We cannot send a large amount of data at the same time. There are several security concerns that are already discussed in the previous slides. Scalability, the network is completely scalable. We have we can have as many number of nodes as are available on the road in a particular scenario, and QoS requirements and the dynamic network topology because of mobility, highly mobile network. These are the basic literature review. that I've gone through, some of the important and recent papers. So that deals with reliable data dissemination in MANET and also with the uh, tracking of malicious node, detecting of malicious nodes in the network. So these are certain review papers, blockchain-based reputation system, real-time malicious node detection framework. So these are the basic thing. This the basic different approaches that are used for detecting the malicious nodes in the network or for sending reliable data in the network. So I have summarized these literature review in this particular slide. Blockchain-based authentication scheme, certification revocation list reviews, identity-based method authentication scheme, credit-based scheme, AI and deep learning for detecting misbehaving nodes and machine learning techniques. So basically, the main approach that I've gone through is credit-based system and using some machine learning techniques. Like each and every node present in the network should be awarded with some credit points at the beginning of the as they join the network. And whenever they send a message, they send it at the stake of some of the credit points. And
Ms.
if they are right,
Sorry for the interruption, but please come to the conclusion. We are short in
right,
time. Okay, you
sure,
only have 10 minutes.
sure, ma'am. This is the last slide. This is the last slide. Yes, this is the last slide. So that is what I'm concluding. That the main since my paper was a review paper, so I have gone through several approaches, several methodologies for detecting malicious nodes in the network and to minimize faulty data and so that to enhance reliable data dissemination in VANET. So the main approach that I'm dealing with is the credit-based system approach. Thank you.
Najil, there are two questions from my
Uh,
end. Am I audible?
Yes, Najesh, you have presented very well. My question is that if the data is authenticated, that also means the data is reliable.
Right, sir. No, sir, no, sir. Actually, data is not authenticated at the beginning. What I'm saying is, whenever a node joins the network, the particular node is authenticated by the central authority. I mean, the central authority gives it some pseudo ID so that it can connect in the network, and then it has the freedom to send a message. Now, the message that it is sending, it should be the reliable one. So that is the area that has to be dealt with.
Means you are assuring the area in which the new user has been added must be reliable. Huh?
Right, sir. The new user which has been added in the network uh, must be the reliable one as it is given as it is having the permission to be in the network by the central authority. So it is considered as the reliable one at the very beginning. But now the messages, I'm actually talking about the messages like now the one who is in the network is the authenticated one. Now, if it has the permission to send the message, it is the authenticated sender. Now, the message that it is sending, it is authenticated or not, that is the area that has to be
Okay,
dealt
that
with.
is a
That is
different.
what.
Yeah.
Yes, sir. Yes, sir.
So, any question from the audience side? Okay, you presented very well, Najesh, and you answered very well. Okay, all the best.
Dr. Soumya Bansal, ma'am, do you have any question, ma'am?
Yes, I have two questions.
Yes, ma'am, please.
Najil, on slide 3, you have mentioned that the full form of VANET is Vehicular Ad Hoc Network. And there, can you move on to slide 3?
Okay, Fatima. Just a second. Here, ma'am, the third one, this one.
It's not visible to me.
Your PPT is not visible, ma'am. Nazish.
Slide
Is it
3.
visible now?
Yes, slide 3. Previous slide.
Yes.
Yes. See, in the first line, you have written the full form of VANET, Vehicular Ad Hoc Network. And here again,
Right.
abbreviation is NET. So what is the full form of NET here?
NET is network, ma'am. That's it. Nothing else.
So it has to be in camel case, right?
It's just. I've mentioned it in. Yes, yes. It's just a full form, and network is the full form for that. Nothing else.
Yes. One more thing, under the challenges and issues slide, you have mentioned that dynamic network topology is one of the challenges that you have faced, right? So what exact challenge you have faced in this? And what is the difference between, dynamic and static network topology?
Actually, in dynamic network, we have the nodes are not stable. They are not at the same position for all the time. The network is established between the nodes that are moving. Here, especially in Venice, the nodes are completely mobile. The vehicles which are running on the roads are mobile and they are completely moving. So whenever they are communicating with each other, so that link between those nodes when they communicate, that link is established for a very short duration of time. Uh, so it is very important that the data that has to be shared should be shared at a very high speed and should reach the destination wherever it is required. And the link is not broken. So the main challenge that we face in a dynamic network is that the link established between the nodes is for a very short duration. And
Okay.
so
So dynamic network topology is not the challenge, but the speed will be the challenge under dynamic network and topology, right?
You can say that, ma'am. The dynamic network is the only reason. Because the node, the second important thing is here, okay, in VANET we have moving nodes, but dynamic network also deals with the changing topology. The topology will also be not be the same. Like the nodes could be could be at one location at a particular time, and it could be at some other location at some other point of time. So the topology is also changing. So that will also be that is also a challenge.
Okay, and how can you overcome this challenge?
There are different routing algorithms which are used.
So you have already studied those algorithms, or you will be studying?
Actually, the area that I'm dealing with is not that particular area. That is why I've not gone through it in depth. But
Okay.
yes, I know some of those algorithms. But yes, I've not gone through them in depth.
Okay. Okay. Thank you. That's all from my end. All the best.
Okay,
Thank you.
thank you, ma'am, and thank you, Nazish, uh, for your presentation. Now we have Mr. Aman Yadav. Aman, are you there? Mr. Aman Yadav? Miss Anupama Verma?
Yes, ma'am, I'm there.
Okay, so please welcome our next author, Miss Anupama Verma, and her paper ID is 200. Paper title is Concern and Difficulties Regarding VNet Security. Anupama, please keep it in mind that you only have 10 minutes, okay, including your question answer session, okay? So you can proceed now. Please share your screen.
Screen is visible, ma'am.
Yes, yes, it's visible, Anupama.
Slideshow is visible, ma'am.
Yes, yes. Okay. You can proceed, Anupama. Thank you.
Afternoon, everyone. And first of all, thank you all of you for giving this opportunity. And today, I'm Anupama Verma from Siddhankar Mahabini University, a research scholar there. Today, I'm going to present the paper which is on the title Concerns and Difficulties Regarding Bennett Security. So here are the outlines of the presentation, like introduction, Bennett Network Architecture, results, and conclusion. Is that the development of vehicular ad hoc networks aims to manage traffic, prevent incidents, and address other transportation issues. So basically, the VANET enhances traffic control and road safety. So due to VANET's enormous contribution to today's environment, the research community has recently shown a lot of interest in VANET application. So this survey paper eliminates VANET's attacks risk, and this article examines many modern security solutions pros and cons. Network security is a challenge in the VANET due to its dynamic topology, so various security measures are needed to guarantee the reliability and security of the VANET. And before implementing any applications based on VANET, network security consideration must be taken into account. So this paper includes some of the concerns and difficulties regarding the VANET security. The goals is that fundamental security criteria, which include secrecy, authentication, non-repudiation, integrity, and accountability, must be satisfied for a VANET system to be considered secure. Taking care of all these things can defend the system against a variety of threats, including unwanted message insertions, airdrops, message modifications, and denial of serious attacks. Some of the table of the attack name, attack type, and attack effects. So here are the VANET attack like impersonation attack, insider attack for privacy and confidentiality, like black hole, outsider, packet attack, and availability. So these are the table of various type of attacks and vulnerabilities. Now in this paper, I have given three types of classifications of VANET architecture. First is the hybrid. The hybrid architecture depicted in figure combines an infrastructure network with an ad hoc network. This is the another potential answer to the VANET problem, even though the hybrid design is capable of providing higher coverage. It nevertheless creates additional challenges such as ensuring a smooth transition in communication between the various wireless systems. Ad hoc network is the network where we have the fixed data systems like cellular and wireless local area networks. So this figure illustrates an ad hoc network which has blind crossings are possible because of vehicle communication. Cellular wireless local area network is used to connect to the internet, gather traffic data, and route traffic. This network design makes use of fixed cellular gateways. An average topology of a wireless network is shown in this figure. Here are some of the results in the discussion, which I have studied from various literature reviews. So overall, the selected references focus on different aspects of driver information system in VANET, including various evaluation, security, and privacy issues and potential applications, while some references use simulations to emulate the performance of VANET and propose new solutions. Other provides a comprehensive survey of VANET to identify required vulnerabilities and challenges. At last, this paper explored how to secure VANET. Security is still true despite the extension. To satisfy VANET security objectives, researchers should focus on developing a security framework that incorporates all of the most of the aforementioned studies. The work in the future would include this. The study looked at the environment, standards, and network architecture of VANET and several qualities set VANET apart from managed cellular VSN communication is facilitated via information routing. In this work, VANET routing protocols are described in depth. A VANET attack classification system takes into account data trust, accessibility, various secrecy, privacy, and non-reputation. That's all from my side.
Anupama, am I audible?
And Mama, what was the purpose of doing this literature review?
Am I audible, ma'am?
Yes, you are audible.
Actually, there is a network issue. Ma'am, basically, this in this literature review, I have studied lot of papers which describe what are the difficulties and what are the concerns required while securing a vehicular ad hoc network.
So, what was the purpose of doing this, study? Basically, you have, detail about what exactly is VANET.
Basically, this
Whenever
will
we do a literature review, it is with some purpose. Like we want to find the resource gap, or we want to analyze what all, difficulties and challenges are there in current literature, and we want to improve on that. So, but
basically this
through your slide, I couldn't find it, any of it.
basically this by finding the concerns and the difficulties, we have found that it is required to maintain our it is required to find out the framework for information exchange. The information which is exchanged and that we have to identify and make them secured from various security frameworks.
Okay, and when are you a PhD student?
Sonia, I have a question. Sonia, are you there?
Anupama.
Yes, I am here.
Oh, sorry, Anupama.
Yes.
Okay, okay, sorry.
Anupama, are you there?
Yes, ma'am. Yes, ma'am.
Okay, so please answer.
So, Anupama, you have identified various difficulties in VANET security. So, can you tell me what security services is more challenging in VANET?
Ma'am, sir, security services like information exchanging.
Pardon, please. Please repeat. Which security service is more challenging? Okay.
Okay, thank you, Anupama. Now we are going to move on to our next author, Mr. Navinitha Gupta. Uh, are you there, sir?
Yes, ma'am.
Okay.
Am I audible now, ma'am?
Yes, yes, you are audible. Please share your screen and please switch on your camera as well.
Okay, ma'am. Okay, okay.
Okay, so welcome back, and here is paper ID is 115 and paper title Implementation of Low Cost ADS-B Receiver Using Software Defined Radio and GNU Radio. You can
Yes, ma'am.
proceed.
Okay, ma'am. A very good afternoon to the Honorable Session Chair, Sri Shama sir, Dr. Soumya Bansal ma'am, Session Moderator Sri Farha Jia ma'am, myself Navneet Gupta, currently working as a Senior Manager in Airports Authority of India, and I am currently pursuing MTech degree from Triple IT Allahabad. Ma'am, my paper is the implementation of low-cost ADS-B receiver using software-defined radio and GNU radio. Okay. So here is the outline.
Sir, please make your
Yes,
slides in. Yes, yes. Thank you.
yes,
Thank
ma'am.
you.
So here is the outline of the presentation. First, what is ADSP, Automated Dependent Surveillance in broadcast mode, then the ADSP message structure, and then the proposed model that we have designed, then the design and implementation of the ADSP receiver, then the flow graph for the reception of ADSP messages, then the result and discussion and conclusion. So first is the introduction. What is ADSP? So ADSP is having is the acronym for Automatic Dependent Surveillance in Broadcast Mode. So it is a surveillance sort of service used in widely in civil aviation, with the help of which aircraft automatically broadcast its positional information along with its velocity vectors and other identity like informations on a frequency of 1090 megahertz without any initiation of introgression from the ground station. In the earlier days of civil aviation, means the controlling job has been done without the use of any surveillance equipment, only with the help of the radio telephony. Later on, we have moved to the surveillance-based equipment like primary radar and the secondary radars. Thereafter, these ADSB have come into the picture, wherein there is no need of means any ground station interrogator. Rather, the aircraft is automatically broadcasting its position information and other related informations. So whoever is having a ADSB receiver, whether it is a ground station which is tuned to 1090 megahertz or a airborne means aircraft, all of them can receive simultaneously the information regarding that broadcast. Okay, so this ADSB optimizes the utilization of the airspace by providing real-time and accurate information on the aircraft position, reduce ceiling visibility restrictions, enhances the operational flexibility by providing the comprehensive data to all the users. In essence, the ADSB provides a pivotal advancement in aviation technology, promoting the safety and efficiency and overall airspace management through its automatic, dependent, and surveillance-oriented functionalities. So, traditional air traffic surveillance systems, such as those based on the radar technology, provide the reliable aircraft positioning and tracking, but these faces several challenges and limitations because the equipment used therein are expensive and their coverage is limited. Means for primary radar, it is around 60 miles, and for secondary radar, it is of the tune of 200 nautical miles. Okay, to solve these problems, that ADSB technology has been widely studied and applied in the recent years. However, there are still some challenges and limitations in the current air traffic monitoring system using ADSB technology. Existing ADSB ground stations are capable of receiving and decoding the ADSB signals, but they usually require expensive and specialized hardware equipment, which limits their popularity and application scope. In some areas or situations or traditional ground stations, they cannot provide sufficient coverage or real-time data updates, leading to the inaccuracies and delays in monitoring. In view of these challenges and limitations, the presented articles aim to explore and provide an efficient method to receive the ADSB signals using RTL SDR and GNU radio. So many studies have already been performed for the reception of the ADSB signals, but there is a research gap for a model which can utilize the full capability of the GNU radio utility software and the RTL SDR hardware. So our model presents a low-cost solution to receive the ADSB signals by utilizing the utility and tools available in the open source GNU radio software using the RTL SDR hardware, and it is a portable solution in which we have installed our operating system over a pen drive. That pen drive we can use anywhere, and we can achieve the reception of the ADSB messages. Okay, so next is the ADSB message
Sorry for the
for.
interruption, Navintha sir.
Yes, ma'am.
We are short in time. You have
Sure,
to
ma'am.
complete it in 10 minutes.
Sure, ma'am.
So
Sure.
please.
Sure. So here is the ADS-B message format. Means basically the ADS-B message is of 112 bits long, and it is consisting of 5 to 6 main components. First is the preamble. Thereafter the downlink format, and for the civil aircraft, the downlink format decimal value is 17. And then the capability of the transponder that is carried by the aircraft. Thereafter the unique ECAU code, which is unique for every aircraft, that and it is of 24 bits long. And thereafter the payload, that is the actual positional information that is being broadcasted with the help of the ADS-B, and thereafter the parity bits for the error detection. Okay, so here is our proposed model. So our proposed model uses the GNU radio software, RTL SDR hardware, and L-band antenna, a coaxial cable, and Ubuntu OS that have been installed over a pen drive in persistent mode. So for the implementation, we have to acquire and decode the ADS-B frame. We have developed a GNU radio flow graph using the higher block on the GNU radio. For interfacing of the RTL SDR hardware, the source block, RTL SDR source block has been used, and the parameters which we have used for this implementation is sample rate at 2 MSPS, center frequency is the ADS-B frequency 1090 megahertz, and the bandwidth is 2 megahertz. Gain of the RTL SDR hardware as 47 dB. Antenna type is L-band, tuned at 1090 megahertz. Antenna again is 2 dB, and pen drive that have installed the Ubuntu in persistent mode. So here is the flow graph that we have designed on the GNU radio. So it contains the RTL SDR source block. Thereafter, we have developed utilized algorithm to reduce this noise. Thereafter, we have used the ADS-B decoder block, and then the output of the receiver in a tabular format can be is being displayed like this, wherein you can see the different aircraft which are under the coverage of our receiver antenna are listed over here. So this includes the call sign, the altitude information, the aircraft speed, the latitude, longitude, and the track angle. So thereafter, this tabular data we have transported to a local server, and the graphical pictorial presentation you can see where we can have some aircraft. So the results and the discussion. The successful reception of ADS-B signals was achieved, demonstrating the feasibility of capturing aircraft data through the device methodology. However, the attended range was limited due to use of non-specialized antenna. It is emphasized that a specifically designed antenna for ADS-B signal is essential to optimize the range of the signal reception, because we were able to receive very few number of aircrafts. The noise reduction algorithm block have been implemented for enhancing the performance of the ADS-B receivers, thereby effects of the environmental noise and EMI have been mitigated, which improves the accuracy and reliability of this ADS-B signal reception. The accuracy and reliability of the ADS-B data received was validated by cross referencing the real-time map visualization what we have received, and through a external website which is implementing the ADS-B data from all over the world, that is Flight Radar 24. So for our particular region, we have cross referenced that the data what we have received and what it is displaying over the Flight Radar 24 are the same. The consistency between these results affirms the credibility of the implemented system. So next is conclusion. So successful reception of the ADS-B signal through SDR makes a significant milestone in developing a low-cost solution for the air traffic surveillance. This achievement demonstrates the adaptability and versatility of the SDR hardware in communication system. This successful implementation can serve as a launchpad for further exploration and innovation in the air traffic management. And this data received can be used to develop a database so that these data can further be used for the optimization of the air traffic management with the help of air traffic flow management system. So this is all from my side, ma'am. Thank you.
Thank you, Naveenta Gupta, sir. for the insightful presentation. Sheesh sir,
Okay, Navinta, as I understand that you are basically using this ADS-B frame for the basically tracking the planes, and
Yes, sir.
you have basically proposed a model that using the open source, which are reducing the cost as well as increasing the efficiency also. Am I
Yes,
right?
sir. Yes, sir.
So basically, have you done any work on the response time of the antenna and the this whatever the planes that are sending the data? So whether you have studied something that how can we reduce the response time that we have received the signals from there, and so that we can get the exact location and their coordinate also.
Sir, what the practical things we have done, sir, with the help of which, if the aircraft is within our coverage, then we were able to receive their real-time locations, and that we have verified with the external website like Flightradar 24. Sir, but that exact means study that we have not performed, sir, like this time response, sir.
Thank you, Navinta. Any question from Samya ma'am?
No questions from my end.
okay, Soumya ma'am.
Okay, thank you, sir. Thank you, ma'am. Thank you,
Thank you,
Para,
sir.
ma'am.
Okay, sir. So as we wrap up, I want to express my gratitude to all our authors for sharing their research and to all of you for your active participation. Our session chair, Sheesh sir, Dr. Soumya ma'am, uh, please enjoy the rest of the conference and thank you for being a part of this conference. Thank you so much.
Thank you, ma'am. And I would like to congratulate the organizing committee of this international conference. You have done very well. And thank you for inviting me as a session chair. Thank you.
It's our pleasure, sir. Thank you so much. Thank you, Soumya ma'am. Now, Farooq sir, please present the memento and certificate to Professor Sheesh sir. Thank you so much, sir. Thank you for your presence.